Assalamu alaikum and very good day. My name is Dr. Javed Iqbal. Welcome to my new video on understanding of feature engineering, feature extraction, feature selection and feature encoding. This video would be very useful for everyone who want to start work in machine learning or those who are beginners to machine learning. My focus during this video would be on key terms relating to features. This slide shows what is a feature or attribute. As all of us know that during machine learning journey we have to come across these terms regularly. I will provide you brief description of what is a feature. A feature is an individual measurable property or characteristics of a phenomenon being observed. All machine learning and pattern recognition algorithms works on features for decision making or getting meaningful insights from data. In machine learning, we use the term feature, variable, attribute, predictor, or property alternatively. Similarly, we can use terms sample, observation, instance, example, record, or tuple, etc. The figure on the right side shows well-known iris dataset. This iris dataset has 150 samples or examples, and this iris dataset have four features. The name of the features are sepal length, sepal width, petal width, and the fifth one is the class label. There are three classes in the data. So whenever we want to start work on any machine learning algorithm, we must have some kind of data. Before start of the experiment, we must be familiar with the detail of the data. The detail of data may be the name of the data set, the features in the data set, number of classes in the data set, data type of each attribute, number of instances in each data set. So feature or attribute is among the fundamental concepts in machine learning. After feature or attribute, the next concept that we should be familiar with is feature vector. This slide shows what is a feature vector. A feature vector is a vector containing all the features for a particular object, instance, or observation. Every dataset has finite length of features in order to describe each sample. The spread of each features in each class can be observed by plotting them against each other in 2D or 3D dimension. Visualization of high-dimensional feature vector data is a challenging and open research problem. The figure below shows the feature vector. Here x is a feature vector, the length of x is d. The next figure shows feature vector space. Suppose our data have three features in 3D feature space. The next figure shows the scatter plot of 2D features. Feature 1 is on x-axis, feature 2 is on y-axis. The data in this figure is about three classes. So here we can see that we can categorize three classes based on feature 1 and feature 2. So in machine learning, the importance of feature is significant. This slide shows the concept behind feature engineering. Feature engineering is also considered an important step in machine learning and pattern recognition. Feature engineering uses domain knowledge of data to create features that make machine learning algorithms to work. Feature engineering is the process of transforming raw data into features that better represent the underlying problem to the predictive models, resulting in improved model accuracy on unseen data. The need for manual feature engineering can be avoided by automatic feature learning. Recent trends are now converted toward automatic feature extraction. Andrew Ng is a professor at Stanford University. He also worked in a number of projects related to machine learning and AI. According to Andrew Ng, coming up with features is difficult, time consuming, required expert knowledge. Applied machine learning is basically feature engineering. So from here we can see the significance of feature engineering in machine learning and pattern recognition. In my earlier video on feature selection and dimensionality reduction, I have provided you an overview of what is feature selection. So this slide shows what is feature selection. Choosing informative, discriminating, and independent features is a crucial step for effective algorithms performance in machine learning and pattern recognition. Feature selection methods also filters irrelevant or redundant or noisy features from data. Feature selection only selects a subset of features from the original set of features and do not transform the original features. So the fundamental idea behind feature selection is to select a subset of features from the original features. The original features are not changed. The feature vector obtained after application of any feature selection technique may have fewer number of dimensions than original data. In my earlier video, I also discussed popular feature selection method. The name of those methods are missing value ratio, low variance filter, high correlation filter, random forest, backward feature elimination, and forward feature elimination, etc. This slide shows the concept of feature extraction. Feature extraction is also known as feature projection. It aims to reduce number of features in a dataset by creating new features from the existing ones, and then discarding the original features by transforming data from the lower dimensional to high dimensional space. These new reduced set of features should be able to summarize most of the information contained in the original set of features. The data transformation may be linear as in principal component analysis (PCA), but many nonlinear. Finally, dimensionality reduction is also done using different type of feature extraction method, and in my earlier videos on dimensionality reduction I have shown you different type of dimensionality reduction techniques. These techniques are based on the concept of feature extraction. This slide shows what is feature encoding. Feature encoding is also an important step in data preprocessing, which represents non-numeric categorical text, etc. data into numerical continuous values. Efficient feature encoding is proven to be very significant in the performance of a machine learning or pattern recognition algorithm. Feature encoding is considered an important research direction to deal with variety of data around us. The data may be in text, speech, or any non-image format. This slide shows popular feature encoding methods that are used to convert non-numeric or categorical data into numerical or real values. The popular encoding methods are label encoding, frequency encoding, categorical encoding, one-hot encoding, or n-gram or sliding window encoding. We will look into each of these in brief. So first, what is label encoding? In label encoding, we map each category to a number or a label. Like in our data, if we have some labels that are not in numeric form, so we can assign some number to that label. The numbers should be unique for each type of label. Next is the frequency encoding. Frequency encoding use the frequency of categories as labels. Frequency is related somewhat with the target variable. So here we compute the occurrence frequency of each attribute or variable based on the number of examples in a dataset. The next encoding method is categorical encoding. Categorical encoding converts categorical data into numeric values. As I have shown you the iris dataset, target class of iris dataset is based on categorical values. So we can convert those categorical variables into numerical variables by assigning a unique value to each of the categories. So for example, to Satosa we can assign 1, to versicolor we can assign 2, and to Virginica we can assign a number 3. The use of categorical encoding is very useful during the classification process. The next is one-hot encoding. In one-hot encoding, we map each category to a vector that contains 1 and 0, denoting the presence or absence of a feature. It can be used to encode categorical text, time series, etc. data in numerical values. The next is the n-gram sliding window encoding. Here n-gram can be 1 gram, 2 gram, or up to or 4 gram, etc. N-gram is a contiguous sequence of n items from a given sample of text or speech. N-gram or sliding window is mostly used for textual type NLP or sequential data. A lot of applications have been developed using n-gram or sliding window encoding method. Finally, this video shows the understanding of different concepts related to features. In this video, we have discussed what is a feature or attribute, feature vector, feature engineering, feature selection, feature extraction, and feature encoding. These feature-related terms are being extensively used in machine learning and pattern recognition related such problems. I hope this video would be very useful for those who are just diving into the machine learning. Thank you very much for watching this video. For more videos, please stay tuned.